What's the difference?
Rider's the fancy one.
Oh.
Got a super fancy camera, so we're gonna try that. Okay, so limits in 3D.
What section?
So this is section 12.6 roughly. Yeah, I'm skipping around a little bit because Jacob's got to go, and this is more important than the other thing. So the other thing we're going to talk about is 12.5 today, which is not super new. I was right, wasn't it?
Yeah.
All right, so I want to talk about limits in R3, and the idea is the same, right? So what was the idea of a limit in Calc 1?
It was converged from both sides to be continuous.
Points that
It's
above
kind
the
of,
term.
that's just what we're referencing.
Let's see.
Discontinuity.
The value
So-
of the graph approaches.
In R2, right?
Yeah.
If I say the limit as like x goes to a of f of x is some value L, what do I mean by this?
If L equals A, then f of x has a limit.
Okay, if f of a is L, then f is continuous, yeah.
And otherwise,
But-
what x is approaching when it's approaching A?
Yeah, so what I mean by this is kind of,
Or what f of x is approaching x?
Yeah.
yeah, so something like if x is close to a, right, then f of x is close to L. Just kind of an, like, maybe the pictorial way to talk would be better. Like, here's A, right? X's that are pretty close to A, right?
Yeah.
Yield f of x's, right, that are pretty close to L. You guys see that? You remember that definition a little bit?
Yeah.
Let's.
Okay, so the same thing is going to be true in R3. Except that now we're going to talk about, instead of x going to a, we're going to talk about the limit x and y tending to some ordered pair, a and b maybe. And this is going to be of a function f of x and y, right? And we're going to say that same thing, right? We're going to say, okay, the limit is a value L if xy close to AB means f of xy is what? Close to L. You guys see that? So this is just a definition of a limit from 2 dimensions to 3. Right? In 2 dimensions, I had this nice picture. In 3 dimensions, I could also draw this picture, but it'll be a bit harder to comprehend. Right? So let me kind of split my axes here. So here's an x and y axis, right? Here's a point A comma B, right? Here's an arrow that means whatever the heck f does, right? And there's some z axis, right? So I kind of took this picture apart into 2 pieces, right?
Yeah.
Okay, and someplace on this z axis is that number L. So what does it mean to be close to A and B?
So it's like x approaches the A values and y approaches the B values?
Yeah, right? Both x has to be close to A and y has to be close to B. So I might draw that like this. right? So there's inputs that are close to A and B, and then the outputs are going to be what?
Close to L.
They should be close to L. You guys see that? So that's what it means for a limit to exist, right? What would it mean for a limit to not exist?
Well, as x and y approach A and B, when f of x, y approach like infinity or negative infinity, it would go off, so it wouldn't approach a specific value.
Okay, that would be one option. Or we could have this horrible thing that happened to us down in the Arboretum 10 minutes
Oh,
ago.
the discontinuity.
Yeah, where,
It's a jump or a,
yeah, some of us were close to A and B, right? But down at the bottom. And some of us were close to A and B, but up at the top of something, right?
So approach two different values.
Yeah. So it went to two different values. You guys see that? The one-dimensional analog of that is kind of this thing.
Oh, yeah.
the
Right.
piecewise functions.
The weirder thing is that in Calc 3 this can happen in kind of not obvious ways. Like this was something you didn't sweat a lot in Calc 1 because this had to be a piecewise defined function and it was pretty obvious when that was happening. In Calc 3 this happens all the time without being piecewise. Okay? So you got to be really, really careful with discontinuities like this. And there's a trick here, which is that you would like to say how x and y get close to A and B.
Oh, you mean approaching from the positive side to the negative side?
Yeah, before we had this positive negative side thing, right? Do I have that same analogy here?
Well, you're not
Oh
gonna
no,
say-
it gets way worse.
You're
Because
approaching
you
to
don't
the
have to
bottom.
worry about just along the axis, right?
Yeah. from
like,
underneath it.
Any way in.
Approaching like this is still approaching, right? You see that?
Yeah.
This makes testing for or establishing continuity in 3 dimensions extremely, extremely hard. Because if you're going to test along paths, you have to test along all the possible paths. Which makes things horrible, horrible, horrible. Okay? You want to see some example?
Yeah.